Hey everyone, welcome to the KE Report, a company update from Graphene Manufacturing Group. In this interview, we're exclusively going to address all those questions that I keep getting on this company, on the three different divisions, the battery division, the thermal XR division, as well as the graphene lubricants. I also get a lot of questions just simply on the company's graphene production. I am chatting with Craig Nicol, founder and CEO of Graphene Manufacturing Group. Company is traded on the TSX Venture Exchange under the symbol GMG, on the OTCQX under the symbol GMGMF. Now, again, everyone, thanks for sending me in your questions. We're going to get to as many of these as we can, starting with the battery division. And Craig, I received a number of questions on the back of that Super G news. Let's get right into them here so we can get to as many as we can. First and foremost, how expensive is it for battery manufacturers to test Super G? Maybe you can talk big picture, just even about how that process happens now that Super G is out in the market, how companies test it, what that process is, please.
Hey, great to be back online. Thanks, Corey. So, testing a battery is a lithium-ion battery, which has been developed for, say, 30, 40 years, is well and truly understood for small improvements that we think we could make, we'll say, with Super G. The standard way is to have a number of batteries made with and without the Super G, and then are tested over a period of time. That time can be probably within a month, but some of these outcomes that we're proposing that Super G can actually provide can take some, many, say at least 1,000 cycles, and that could be many months. Then, as a result, depends on what charging rate. But you're typically talking about running a batch size of lithium batteries of somewhere between 20 and 100 lithium batteries with and without our Super G. And it's a pretty prescribed process. We've helped them through it, and we've helped a number of companies already through that. What's really interesting is we make a 100 in terms of the carbon electrode from graphene. And what we found really interesting is these big companies that we're kind of working with, they can't do that. That's quite really interesting. That's something that's mind-blowing for them. They're normally only very small amounts of dosages. So when we say, we can make a whole entire electrode out of graphene because that's what we need for our battery, these companies are really quite interested in that. That's not normal. And so when we say, well, yeah, you can add this in small percentages, then, it gets quite doable and easy. And it's something, it's quite a standard process that they would go through on trying different additives. So, anywhere from probably 2 months would be the shortest period, I think, through to 6 months, but they would get data as they cycle them through over a number of months, and then they'd be able to come back over that time to see, how things change with this. A lot of the benefit will be provided at the back end of the cycle. So some of the real data won't be until it's starting to, where a lithium battery starts to deteriorate because it starts to get plugged up with the lithium, and it doesn't tend to go back on the ions don't tend to come back. So as a result, which is when we think we'll actually add some benefits. So that'll mean, some of them will take the longer time period there.
Okay, just to bring everybody up to speed, Super G is something we talked about on the last interview. It's a graphene slurry that it seems like it can enhance the performance of lithium-ion batteries. To this point about testing, then, are you able to release any testing stats on Super G itself, or does that have to be done on a case-by-case basis depending on the type of lithium-ion battery you're testing Super G on?
So yes and yes. We're going to be conducting some Super G tests ourselves with another kind of battery development laboratory, because we will never be able to release the information we get from our potential customers. That's generally quite confidential information. So when we are able to do that, though, it will be different outcomes for different type of chemistries, and there are all different types of even chemistries of inside lithium, manganese, nickel, cobalt. There are power batteries, there are energy batteries, and they're all different mixes. And same with the lithium iron phosphate type. There's a number of different chemical mixes. So I think we'll try to do the vanilla approach up front, but then with all this, as in everything we've done, it'll always need more detail, more information on the specific, types of battery chemistries. But the overall basis is that it's a far more conductive additive and higher density than what we see out there on the market, and as a result, can improve the conductivity and reduce the resistance, which then reduces the amount of heat that the battery makes, which then also makes the battery more efficient, which also makes the battery longer lasting. So, and it also enables you to charge faster. Generally, we've seen that as well. So there's a range of opportunities that, any one of those things, or all of them, or whatever, or, some of them they might get more than others, and different battery companies want different things, and, they're searching for. So they'll have to see what they want, and then come out of that, and wanting to press ahead.
So on the front of producing Super G, then I had a listener note that it seems like Super G is made only of graphene. I don't know if that is the actual case, but does that make it expensive to produce? Can you give us a general cost profile of Super G?
It's very economic for a battery company to be able to buy Super G. I don't want to go into pricing because that's kind of competitive information, but suffice to say, the market right now for these types of additives, is well defined, and all we'll be needing is about 1% of our graphene in the cell to make it work, to make it do what it needs to do. So, it's quite economic because any price you multiply by 1%, and as a factor and as a result, in total impact on the cost per good is, really quite easy to kind of see how people can do it. They've obviously got to see the data first. Generally, a lithium battery needs to have cost of materials below $20 a kilo, generally, although the anode sits at about $6 a kilo as a conglomerate type material cost. And 1%, we can see that will fit within that or under it. So I think that shouldn't be an issue. What will be the issue is seeing how it responds in different batteries and what the battery companies are wanting out of it. That will be the issue we've got to work through.
So for this graphene that's used to produce Super G, or even the graphene that you use in your batteries, does it need to be more precise in a way because of the fact that it is such a key component in either Super G or your own batteries?
Yeah, so Super G is a product. It's not raw graphene. It is our graphene, and then there's many process steps after that we've learned how to make this. It's a fundamentally different product than raw graphene, but it is made of our raw graphene. So it is optimized for battery cells, but what we can do is optimize it for different types of ions. In effect, what our carbon can do is store ions really cleanly without, much resistance or much less resistance, 2.5 times less, in fact, normal graphite. And that's massive for any battery. Storing ions is what a battery does. So ions are just atoms without electrons, and the electrons go around and power your phone or your motor on your car or whatever, your laptop, and then the ion goes across and meets it on the other side. And you just got to store the ion efficiently so it can come in and out. And our graphene does that really well in our lithium-ion battery, and we've seen it do well in customer prior conversations and work with lithium-ion batteries. And now we see the results come out showing our market reduced resistance for the graphene. So you put all that together, it is a big opportunity, and that's why we've had some pretty big companies who are testing it. That's why we're in Forbes on it as well. It's not a small thing. So we'll get through that and we can optimize it. We have all the equipment to optimize it as we need it. And, it'll be a very interesting outcome over the next couple of months as we start to get some responses back.
Now, is there a general time frame we can put on getting Super G up to a product that can be put into market in terms of generating some sort of revenue for the company?
Yeah, I think that there'd be, a pretty serious amount of conversations and, technical commercial negotiations optimizations around how they want to use it. These are products that they've got a testing profile that needs to be understood with very high accuracy, not as high as, say, a medical product, but which it needs to basically work 100% of the time, but pretty close to. Everybody wants their battery to work straight away, all the time, and never fail. So this is something that it will protract the conversations, but as a result, and so you probably wouldn't see sales within a year of any note, because we'd have to build the factory for it, which we're obviously working on at the same time for large volumes, that is. But it's really around getting in a product that is really difficult to replace because of our ability to make such a high quality carbon product, and then creating that differentiation through our multiple processes to make the slurry. What we're proposing is really quite revolutionary. I don't know if that's really understood. Typically, battery companies buy some graphite and then they crunch it up themselves and then proceed to do an enormous amount of work to get to a slurry. And what we're saying is we'll sell you the finished slurry, so you don't need to worry about the rest of the steps. You guys make batteries, we'll make the slurry, we make the graphene, we make the slurry, and then you buy that and you put that into your battery, fully ready to be applied onto the substrate. That is not a normal way for the industry to work. As I said, they typically buy the carbon, the graphite blocks, and make it themselves. And we think we can really do that better with our graphene and the way we've learned how to make it into a cathode. And, we think that's why we're offering this as a slurry.
Okay, let's talk about the companies then, your own companies, Graphene Aluminum-Ion Battery. Any updates you can give us on the testing of your pouch packs or anything that's going on with that joint development agreement with Rio Tinto?
Yeah, thanks. I mean, all we can say is we're working through it. We've done the update, which was quite a detailed update at the AGM in end of November, where we went through, the near 800 or so cells we've made last year and near 200 different scientific experiments across 10 different areas of our weekly sprints. Because we can charge and discharge the cells so fast, we can do a weekly sprint. But if it was, and therefore every week we can see what's going on and jump on to that problem and go into the next issue and jump on that and just keep doing that week to week. With a lithium-ion battery, you just can't do that because it takes you days to charge, whereas we take, in some cases, minutes, so much quicker. So as a result, our weekly turnaround on things is probably 4 times faster than a lithium battery can do. You probably have a monthly sprint when we can do weekly sprints. And really, a lithium battery, probably, you might not be able to even do that. You might need to do double or, triple month sprints. So our ability to really progress through that was demonstrated in our ability, the fact that we've done so many different cells and so many different scientific experiments in a controlled manner. That's probably not really well understood on how we are such a disruptive space there. And that is the reason why we're doing what we're doing. We'll be coming out shortly with a full update and, on the battery space. And there's a lot of moving parts, but we're setting ourselves up for success for that business sector. It's got a lot of attractive features about why people want to see this type of battery in their whatever device that their or vehicle or application. While we're working with Rio Tinto, one of the largest mining companies in the world in this space as well. And all of those things haven't changed. They're all still very similar to where we launched and where we said in the update. And we've just got to work through it. And it's deep science, but it is world leading and very attractive deep science.
All right, Craig, I'll follow up with you when we get more news on the battery division. Let's move over to the thermal XR division. That's where a lot of news has come out recently. Even our last interview back in the middle of December talked about some data around heat sink miniaturization. Some questions on the back of that. We're wondering if you've tested TXR, thermal XR, on any materials other than aluminum, because most of that data, it looked like, was dealt with aluminum products.
Yeah, and it's basically the same across different materials. We've certainly done a lot of work on copper. It's basically the same or slightly better on copper. It's fine on stainless steel and others. So many different materials. What it doesn't like is a corrosive rust. So if we do it on carbon steel, we've got to take that kind of sheen rust off before we coat, and then it'll work there as well. It's really got to create a really clean surface to coating finish, and that's really enabling it to do what it does. So there are various, good news stories happening there. We can't announce them yet, but there's a lot of work going on behind the scenes in that space, both in manufacturers and service opportunities as well as distribution. Obviously, we're very keen to progress the EPA and finalize the EPA approval in America because we have sales orders waiting to be delivered there to our partner in America, New Calgon. And that's, going strong in behind the scenes, waiting for the EPA approval. So, we're preparing for that. In the meantime, there are many other sectors that are kind of coming on board, and electronics is definitely one that is becoming, quite topical and in the business, and electronics heat sinks are, I think, are really going to be quite a large opportunity. As we said, we think there's some substantial volumes there. I think $120 million per annum at least of opportunity of sales in a small portion of the market, very small portion of the market. So, and that we've already had a number of heat sinks from different global manufacturers already being tested, and that's really quite exciting, and I think should show some really good progress. But right now, once we make the progress, we'll definitely announce it.
All right. On the back of, I guess, this TXR, because the company has released other products in some of your other divisions, I had somebody asking, are there any other variations of TXR that are in development, in testing, kind of to your point there, if it works with so many different products, do you need to refine it to work even better?
Yeah, so I used to have a role in a company where I had something like 2,000 products and technical products and various different pack sizes. And it's definitely an opportunity, but also just got to manage it carefully as well because it becomes a monster of stock issues and other things. So we have, likely, we obviously rebranded from Restore to Enhance last year. And now we're really focused on delivering the sales into the different parts of the sectors as I was just talking about. But there's always going to be the opportunity to go into variations as we can actually vary the base coating, and we can vary the graphene and the mixing and then spraying technology. And there are many different variations we can provide through our factories because we control it all, and on how it's sprayed and serviced. So we have got many tempting opportunities there. Data centers is definitely going to be, a pretty big opportunity for us, and how we actually, launch that, is going to be one thing. And heat sinks is definitely a different market. Air conditioning is definitely another market. Then there's an industrial coating opportunity, which is keeps presenting itself with a number of different opportunities there. So there's genuinely quite a lot of, many different ways this could flow out. What we're really trying to push through is our beachhead air conditioning, and then many others. Obviously, battery pack cooling is another space, being able to provide pretty considerable battery pack cooling just by the coating on the outside for the lithium batteries. That's another area. It's almost endless, Corey, and it's actually always been a problem with a graphene business, is that the amount of opportunities are just totally endless. And I could have a new opportunity sent to me every week, and I could just look at that and not deliver. So I don't do that. I focus on pushing the sales through because we're creating completely new ways of thinking around heat transfer and also corrosion resistance. And that is what I'm here to do for our shareholders. So that's what I focus on. And then as we come along, we might create different variants, but it'll be in a very controlled manner because it's very easy to get excited and then fill your warehouse full of stock that, doesn't move exactly the way you thought it would.
So if there are this many opportunities, then is there an avenue that is higher margin for TXR? And also tie that in with another question that was asking about the cost profile. Just how expensive is TXR? So what does that then limit maybe some of the divisions, some of the industries that you go into?
Yeah, in a manufacturing sense, where I don't know the exact cost, but we wouldn't be more than 5% of a cost factor for a big air conditioning system as an add-on. So costs are generally not the issue, and that's in even kind of a bulk, supply situation. And even with that, we would have pretty good margins around that. We've got a good line out on how we can see our cost control going forward. We think there's a lot of cost there we can actually take out as we build the volumes up. So that also is something we see a lot of future in the business. So both in terms of now current costs, which obviously probably the highest hopefully that we'll ever have, and then as we progress, we'll start to take costs out of the product and then start to push into different sectors. But the real basic, good value and really good return for the company will be on the big OEM point supplies, which could be anywhere from 100,000 to 1 million liters a year each. Really good value for company and shareholders, and also for the customer, because it provides them something that they can't get pretty much otherwise. So that's the space that we're pushing. They're big elephants, some of these guys, and that's really where we want to be for helping them and helping us. But it is a very deep tech type development program with these guys. In the meantime, we have numerous distributors that are selling it throughout different channels around the world. That's still going. But yeah, the big OEMs are the ones where we're using all of the industry data that we've had from many years around the world to show that the manufacturers, they should adopt this technology. And then that's the space we're in right now. And then it's quite a detailed, deep tech kind of conversation.
Since you are working with so many large companies, or large companies are testing out this product, is there a chance that one of these companies would just simply say, we like the tech and we will buy your company, rather than just enter some sort of supplier agreement?
Yeah, I don't want to say it's not possible, and I don't want to say it will happen. But what we tried to do all along is always have multiple parties working with us. So, we can always have multiple big companies working in and around us. So if someone does try to do that, which I'm not saying they are, I don't want to in any way give that, false representation. But if someone does do that, then we have cover from potentially somebody else who might go, I don't want that. Because we're working with so many different industries that, who all could do that, with probably their legal bill for a month globally. But that's definitely not a target of ours. That's not what we're trying to do. We're really trying to push into this commercial operations space. We do see that's very near. We do see some big opportunities in sales coming through soon, and that's what we're focusing on. And, I think we're in so many industries, so many opportunities, that it would take a bit for someone to do that, because I'd really have to understand that there'll be other companies who will go, no, wait, you can't do that. I'm working with them, and therefore create problematic issues. I've worked in multi-billion-dollar takeovers. I've kind of done being commercial manager of some of them in my last career, and they're very complex and they're very difficult to pull together when the company is still in development phase. So, I think, well, regardless, we need to get commercial operations. And then, if someone wants to have a chat with us, fine, we'll work at partnering, but certainly we're not in any way trying to look and focus of just selling the company. It's not the space right now.
Okay, so since it's all about commercialization, I do need to ask about the EPA testing in the US. Any updates you can give us on that front?
Yeah, it's a very detailed conversation. It's very engaging. It's certainly different to what we submitted a year ago, where we didn't get that. So, we feel confident that we are getting, heard, we are getting listened. The product has got a lot of big companies kind of interested in America going, where is this? But in the end, the EPA has got to do its thing. We don't know what will happen, or anything will change once the new president gets installed later this month. We're just pushing through all the questions that we get answered with good answers to the extent that we can. Otherwise, we'll go and find out all the details and we'll go back and give them what they need. It's a very detailed, engagement process. We have gone through this with other countries, but you can already get, graphene food chopping boards and heating boards for food use in America on Amazon. So, it somewhat deflates you when you realize that there's graphene, food devices already being approved and used in America, and our coding for saving energy and saving emissions is being worked through. But that is what it is, and we've got to take it what it is. And people are asking questions that they need answered, and that's what we're going to go through. And we feel confident that we're getting more engaged than ever before, so we feel confident that it should be faster as a result. But we, obviously can't promise that.
So since graphene is such a key product to all of your products and you create your own graphene, can you tell us about how the process is of scaling up this graphene production when you do get to market and commercialization, you can move any or multiple of these divisions forward?
Yeah, and that's what we've been always working on ever since we started the company. And I'm basically the Chief Technology Officer, and I have been working in this space for some time. And we've got a next generation graphene production process that we're working through. It's really quite exciting, and we'll announce more of that coming up. But we will obviously, and we have always been focusing on quality. That is the most important thing when you're making graphene. Making a product that doesn't do what it needs to do, or you need to add, say, 10 times more than you did because you didn't make the right quality, is not where we've ever been. We're highly focused on very high quality for the specific tasks that we're applying for it to use. That's how we've grown the company to where it is now. It's quite a unique approach, and production really doesn't mean much unless you're actually selling it. So we feel more confident this year than ever about scaling this. We've been running our new generation modular graphene production system for more than a year now, and we're getting great data. And as we've said at the end of last year, we're now making the best graphene we've ever made, and for the highest production rate we've ever made it. So all intents and purposes, it's all going in the right direction. The costs are acceptable for where we are now, but we know we can do better for many different reasons.
All right, Craig. Look, thank you everybody for sending in a lot of these questions. Still have a couple more, but this is running a bit long. So just two more quick questions, and everyone keep emailing me your questions, and I'll follow up with Craig in another couple of weeks. One major question that I get all the time is you talk about how many large companies you're working with. People are always wondering approximately how many large companies are actually testing your product. What kind of ballpark number can you give us?
Yeah, so when we went to market with our AGM presentation at the end of November, it was about 15 or so, and now it's about 30, all very interested in how we're testing our products or waiting for the testing of the products. So it's a very intense amount. There's lots of small companies as well. I'm not just saying that's not the only thing we do, but yeah, it's become strategically very interesting across all of our 4 products. Over the last couple of months, something has happened. I don't know what it is, but yeah, the interest level's definitely gone up a lot.
So, Craig, final point then. Just give us a little lay of the land in terms of what sort of news could be coming out in the near term out of GMG, please.
Yeah, so we do expect to do a large battery update, kind of have a real good overview of where everything is at. There's a number of good things there we're bringing together, and once they're final, we'll be able to announce that. Graphene lubricant engine data should be coming out shortly, and that will be, a big outcome of years of testing on this product that we've been making now for many years. But we've got lots of customer data. We don't have actual engineering data, and this is going to be actual data that we can announce very clearly, showing what it can do. It's very exciting. There are also, obviously various different conversations we're having with our thermal XR coating and Super G area. And then obviously we've got, a number of patents in different spaces that are progressing as well, which is also very exciting. So if there's any number of means for us to having to announce things in coming months, which is very exciting. And we'll need to, work through that like we have on everything else, just keep pushing it on and then, tell people as it happens.
Okay. Craig, thank you very much for the update. Again, everyone, thank you for sending in all your questions, and please keep them coming. I do my best to get Craig on the show to address those questions in between different news releases. Again, my email address, fleck@kereport.com. And I am, again, chatting with Craig Nicol, founder and CEO of Graphene Manufacturing Group. Craig, very much appreciate your time today. Thank you for addressing these questions.
Thanks, Corey. Talk in soon.